Hey everyone, today we are going to build our personal AI data scientist. So without wasting any time, let's dive right into it. So this is the UI of our AI agent. You can give a task input, attach a file, which is optional, and you can describe your task here. So let's browse your file. This is the housing data prices from Kaggle, and I'll describe the task like analyze this data set and show insights, create multiple models, and compare these models and suggest the best one. Create production ready function to inference the created best model. So this here is the file name that the model that the agent will create. Uh, okay, let's hit start. And then if we see here, there is no Python notebook file which is created in this directory. So the first step is for creating the subtasks, which the agent has created successfully. And now we can see the Python notebook here. Let's check. So the step one is to load and inspect the data set. So there is some error in the path of the file. So let's say if it is able to rectify it. Yeah, it has added this R here. So this will rectify the error and it was able to read the data set. That is great. The second step is data pre-processing, missing values and categorical variables. Okay, it has used one hot encoder, standard scalar. That is nice. Uh, Third step is for EDA. It has used matplotlib and seaborn libraries. So it has got some error and it is handling the error. It has got an error again. Yeah, now it has solved the error and the plots are saved here in this directory. Fourth one is for feature selection. Okay, nice. And this is splitting the dataset into training and testing dataset. And the sixth step is model creation. So it is using some metrics to find which is the best model, and I guess it has decided 4 models to test with. It has got all the scores and there will be some error here. Yeah, it has corrected that one. Okay, so the best model is random forest model with its accuracy, and this is the function to inference the model. We have got some error, it will rectify it. Yeah, till then let's see our plots. So these are the saved plots. Okay, looks good. So this is the AI data scientist that we are going to create by the end of this video. So before we fire up our VS Code, let's plan this AI agent development. So this plan can be applicable to development of any AI agents. So let's break it down. The first thing that we are going to do is define our goal. So for this agent, we want it to be able to create new Jupyter notebook, add markdown cells, add code cells, execute those code cells, and then grab the output of the executed code cells. So this is the basic goal of the AI agent. The success criteria of this is very simple. If the agent is able to do all the tasks mentioned before and is able to create a complete project from the task given and the dataset given, then it's a win. So the next one is we pick the tools for our agents. This could be external APIs, libraries, or custom built tools. So for our agent, we are going to create 2 tools. The first one is Markdown tool that will be used to add and format Markdown cells. And the second one is the code cell tool. So this tool will be used to add, execute, and manage code cells. Moving to the next step, the third step is to design our multi-agent system. So this includes defining what tasks the agent will do, like assigning roles and responsibilities to our agent, basically providing instructions so that the agent can perform smartly. So here in our case, we will have 2 agents. That is a task breakdown agent. This agent will be breaking down the main task into subtasks. So what we have seen earlier. So this will be the task of first agent, and the second agent will be Jupyter Notebook agent. So this agent will be able to handle the subtasks that we give it from the first agent and then manages the notebook and executes the code cell. So these are the 2 agents. Now that we have selected the agents, Next is selecting the best agentic framework on our use case. So we basically need something simple, efficient, and which gets the job done. So basically something small. So we are going to use small agents by Hugging Face here. It's the best for building AI agents with minimal code. So after this, we are going to select the LLM for our AI agents. So we are going to use Grok API as it is free and good for testing applications. So the last one is the execution of the AI agents. For our use case, the first agent will convert the task into subtasks, and then these subtasks will be provided to the next agent. So these processes sequential. So now that we have planned our AI agentic project, let's execute our plan. So a simple disclaimer before trying this project out. So all the code execution that is done, it will be done in your local system and not in a sandbox environment. So please do monitor what those code executions are performed by the LLM. You can add the sandbox execution as a feature in this project. This project will be available in the GitHub. So let's open our VS Code and then the terminal. Here we are going to use UV to initialize a project. If you don't have UV, just install it via pip. And let's go with UV init. So this will initialize some basic files here. And let's create our virtual environment. This is created. Let's activate it. Now that it has activated the environment, let's go here and create our tools folder. So in this tools folder, I'll create one file called as nb tools. So this file will basically host all the tools that we discussed before. So let's import all the required libraries. We are going to use nb format and nb client here for using those tools. You can add UV add nb format to sync the dependencies in our pyproject.yml file. So it will sync those dependencies. If you go to this file, as you can see here, the dependency is added. So similar to this, we will add it for nb client too. UV add nb client. So this has added the dependency. The first function is for creating a notebook. So it will check if the path exists and will create a notebook. The second one is for saving the notebook. So it will write all the contents and save the notebook. The third function is for running the code cell. So it is, run code cell. It appends a code cell to the notebook, runs it, and then returns the output of the last executed cell. The arguments here is the code as a string, and it returns the output of the last executed code cell. So here we are using notebook client and the kernel name is Python 3. It will execute it, save it, and then return the last executed code output. The last one is add markdown cell. So it appends a markdown cell to the notebook and saves it. It accepts markdown content to include in the cell and returns the status. So now that we have created all the functions, we will convert these functions into tools, small agent tools. So from small agent, import tool, and let's add here small agents. Now that the dependency is added, let's add a tool decorator. So this will convert our function to our small agents tool. We will convert the run code cell and add markdown cell. So these are the two tools that we discussed and that are required for us. Now that we have created the tools, let's test it out. So I'll create a notebook first with this name, and then we'll add a markdown cell. So this is just a simple markdown cell. Let's execute it. So it will create our notebook and then add a markdown cell. So let's check if it has done it. Yeah, so it has created and it has added a markdown cell. So let's test the other functions too. After this, I'll add code one, which is basically importing pandas and then creating a dictionary and then adding those dictionary as a data frame. So run the code cell and get the output of that code cell. And the second code cell, we are going to use the data frame that is created in the first code cell and we are printing the average. Let's check what it does. Yeah, so here we have the markdown, we have the code cell. Now it is executed. Yeah, we have the output and the second markdown and the second code cell and also the output. So it looks great. The tools are working perfectly fine. Now that we have all our tools created, let's move to the backend of our AI agent. So here I'll create one more file called as nb backagent backend.py. Yeah. So here we will add from small agents. We will add all the model providers that small agent support, so it becomes easy for you to use any model. So inference client, light LLM, OpenAI, for transformer model, and we have code agent and the tool calling agent. So these are the two agents supported by small agents. Now we will import all the tools that we have created. So from tools .nb tools, import our two functions. So one is markdown cell and the other one is run code cell. Yeah. So the next step is for selecting our chosen inference. So here currently it's HF Hugging Face API provider. We have multiple providers like Hugging Face API, Hugging Face API providers, and then Transformer. After that we have Olama. The next one is Light LLM. So you can use any model provider that you like. Last one is OpenAI. So I will be using Light LLM. So I'll change the chosen inference here to Light LLM. Now that we have done the model configurations, we will add our Jinja templates. So these are basically prompt templates that we are going to use for our AI agents. So let's import all the requirements. The next step is to render our prompt template. So what it will do is it will search for the directory called as prompts, and then it will take those prompts from that and will render the template with our own variables in the prompt. So it takes a template name and the variables here, and it will render the prompt template completely. So let's create our prompts folder here. Yeah. Now that we have created the prompts folder, the next step is to create a function to generate agent stream. Let's generate that. It takes file path that we provide, and the other one is user input. So if file path is provided by the user, we will provide it as a string to the LLM, and if not, we will just provide the username. The next part is you initializing the first agent that will convert tasks to subtask. We are going to use code agent here, and this is the basic description for the code agent, that is our first agent. So here we have the max steps. I'll put it as 1, and the model which is defined here. So the first agent is ready. Let's render a prompt for that. So here I'll give a file name. Subtask prompt is a variable for the file name. Yeah. So this is the file directory. We will create it under prompts, and we will paste the prompt here. So this is basically a prompt to generate subtasks from tasks. So here I have mentioned some important rules, like if you are able to create function, then create it in one code cell only. Similar to that, you can read it afterwards. And this is our main task. So this is the variable that the prompt will be rendered. Next up, we have to run the agent. So we are going to give the prompt here and then run. Let's start with the second one. The second one will contain all the tools. Now delete this. Even this is a code agent, and I have also provided the model here. So this is a code agent. You can use a tool calling agent too for both the agents. It is different types of agents that are supported by small agents. Now that we have created the second agent, let's create the prompt template for the second agent. Again, same the directory. Let's create the variable with the file name. Yeah, here. So nb agent prompt.j2. Let's create that file and paste our prompt there. Yeah, let's paste it here. So this is the second prompt for our second agent. It will contain all the subtasks. So it will work on the subtask, add markdown cells, and also add code cells executed. And if there is an error, it will re-attempt the subtask and then try to solve the error. So these are some of the rules that I have mentioned here. So for errors, I have mentioned this point. If there is a missing dependency, you can install it via this. So this is why I have provided the disclaimer, and the task and the subtask are given here. So this is the complete prompt that we are going to use for the second agent. Now that we have the prompt, let's run the agent. nb agent.run and the prompt. So here we will use streaming equals to true so that we can visualize it in our UI. I'll return the subtask and the agent stream from this function. Now that we have the backend ready, let's create our front end. So we'll create a file called as nbagentui.py file. Here we will import the backend that we have created. So the function is generate agent stream, and we will import the tools for creating a notebook. Yeah, these are the two required things. After that, okay, we are going to use streamlit for UI. We will add it in our UI dependencies. So here it will be as st. Let's import some other dependencies that we are going to use afterwards. Path for creating a directory, and then import regex for getting the output from the agent streams. So this is the custom CSS that we are going to use for all the code blocks that are being shown in the UI. This is the temporary directory. So whenever a user will upload a file, it will be saved in this temporary directory. Container, then the header. So this is the sidebar of the UI. We have the file upload box, and then the task description box where you can input our task. After that, we have the input for file name, so notebook name input. We are going to add the extension here. Yeah, so if the user presses the button, start button, it will do all this. So it will first create the notebook and then check if the file is uploaded or not. If the file is uploaded, it will save that file in the temporary directory. Now we have the chat container. So here we are showing our user task. Then we are showing the file uploaded. So if the file is attached, we are showing that. And after that, we have the output file name. So these are basic input given by the user. So we are showing that first. And then we are calling our backend. So this generate agent stream where we are passing the file path and the user input. So this file path is basically from the temporary directory. Now let's go to create the subtasks. So this will print out the subtask that is created by the first agent. And let's check the agent stream. So we will iterate it. So for debugging, you can use this with chart container. So here we will be adding all the streaming output. So these are the attributes that the agent stream will have. So first is tool calls by the agent that we will display it. Second one is the model output. So this is our LLM output. The third one is the observations of the AI agent. And the last one is action output. So this is the final output. Once this is done, we are going to print that analysis is complete. And then I want to give a download button. So for that, let's get the notebook path, and then we will check if the path exists, and we will give the download notebook button for the user so the user can download it anytime. So this is basically the UI that we have created for our AI agent. So the UI is done, but we still have one thing to figure out, which LLM that we are going to use. So I will be using Grok. So for that, I will be needing a API key, Grok API key. So let's get this API key. Navigate to grok.com, and here you can go to developers and the free API key. Create your own API key here. Then go to the documentation, models, check the list of models that are provided by Grok. You can select any model as you want. I will be selecting this one for now. Let's go here in Light LLM and change the model configurations to this model. So here we have OpenAI as the provider, and this is our model ID. And this is our base API URL, and the API key is added here. Now that we have all the things, let's fire up our UI. Streamlit run. Let's hit enter. So this will fire up our Streamlit UI. Here we have the browse files option, but we are not going to browse any files here. Let's test it with something simple. Create sample data, show me the first 6 rows, and the file name is test. Let's start. So this is the user task. As you can see, there is no file that is created yet. When the subtask appear here, the file will be created. Yeah, the subtasks are here. Now that we have the test Python notebook file, let's check what it has done. So the first is import necessary models. That is correct. Second one is create sample data. Good going. And the last one is display first 6 rows. So it has done the job. And we also have the summary that what it has done in this Python notebook. Let's navigate back here. So as we can see here, we have user task, subtask, and the tool calls. So here we have two tool calls, that is my add markdown cells, and the other one is run code cells, which we have already created. This is the thought. So this is the thought from the LLM and the observation. So the last executed cell. And to the end, we have analysis complete, and we also have the download notebook button. So it downloads the test Python notebook here. I will be uploading this tested notebooks for directory in the GitHub. So here I have tested multiple scenarios. So here I have the prompt that I have tested, and the below is the exact notebook that is created by the agent. So here I have told it to teach me Python. The second one is for spam ham email classification notebook. Here I have took the Kaggle data set and uploaded it. So this is for end-to-end creation of data science project. It has also created a final model pickle file. Here we have data visualization Python notebook. So all the plots are mentioned here. You can find all these notebooks created by the AI agent in the GitHub along with the whole code. Link is in the description. Go check it out. So that was it. We have created our junior data scientist. If you enjoyed the content, drop a comment below with your thoughts. Don't forget to hit that subscribe button for more such awesome content. Thank you.